Okay, do you want to start with the complete? Let's start with the complete. 7 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7 carbons. Okay, so this name is 5-chloro-3-methyl-hep-2-ene. Okay? Alright. What's the most important, please, folks? What's the most important functional group here? The double bond, the ene ending tells us that's the most important functional group, okay? Ene endings are more important than the chloros or the methyls. Okay? So what we want to do is, well, and it really doesn't matter. When we're drawing the structure, it's going to come out the same anyway, okay? So I'm going to put my double bond on the second carbon, 2-ene. That makes sense?
That's where the 2 comes from?
Yeah. All the numbers in front of the functional groups tell you where it's located. Okay? So you can put it either here or here. Doesn't matter. Okay, but if I put it from here, I've got a number at 1, 2, 3, 4 from the left side. I'm going to put it from here. There's the 2-ene. Okay? On the third carbon, there needs to be a methyl group. How many carbons in a methyl group? 1. Meth means 1. Okay? And then on the 5th carbon, there must be a chloro group. 1, 2, 3, 4, 5. So that's a Cl. Now all I have to do is flesh it out. Okay? How many hydrogens do I need to put on this carbon? 3. So every carbon has to have 4 bonds. So I need 3 hydrogens on this carbon. Hydrogens are the terminators. Okay? There you go. How many carbons? How many hydrogens on this carbon? 1. How many hydrogens on this carbon? None, because it's already got 4 bonds. How about this one? 3 hydrogens on this. How many hydrogens are here? 2 on this one. How about this one? 1 here. 2 here. 3 here. And there is the complete structural formula. Okay? So now we have to go and write the condensed formula. So we're going to condense each of these groups. Now I'm going to put circles around them. That doesn't mean you have to do that. That's not really, I'm just doing it to help us name it, okay? So you don't really need to put circles around this stuff, but I'm going to circle the carbon groupings, okay? This is one all by itself here. This is a side grouping here. Alright. So, kind of. And there is an electron cloud. So, there you go. So this is going to be a CH3 here. Here we're just going to have CH. And I have to draw the double bond. I don't have to draw single bonds with a condensed structure. Okay? Have a single carbon here with no H's on it, but I've got to put a side group CH3 on it. CH, but I got to put that chlorine on it. Okay? Then there you go. There's the condensed structural formula. Okay, so for a skeletal formula, I need 1, 2, 3, 4, 5, 6, 7 carbons. So I need 6 bonds. Right. 1, 2, 3, 4, 5, 6 bonds. Okay? Alright, so all I have to do is go through and find the second bond is a double bond. Okay? Double bond there. On the third carbon here, I need another carbon sticking off there, methyl group. And on the 5th carbon, 1, 2, 3, 4, 5, I need a chlorine. 1, 2, 3, 4, 5, need a chlorine here. And we're done. So this is 5-chloro-3-methyl-heptuene. Okay? Yeah. You always have the same test references. The only thing that's going to change is in Unit 9, I will add a section to the test references for, let's see, acid-base indicators. I haven't done that yet because that has to be in color. It's going to be printed on white paper instead of blue paper for your test references. And I have to print it on my color printer instead of a copier. What? When I ask you to. So net ionic equation, complete and net ionic equations, at this point in time, you will only write those if I ask for them. Now, the importance of those will not be seen so much in this class. The importance of those become much clearer. Well, they become pretty clear when we get to the acid-base unit, somewhat. But they become really clear and important when you get to redox reactions that you don't do in this class. Okay? So there's no redox in here, but if you do AP chemistry, you will be doing redox, and you need to know how to do it. Okay? Redox equations cannot be balanced with one equation. You have to actually break the equation in two parts, balance as two separate parts, and then we put them all back together. So what we're doing is just laying the groundwork for that at this point.